Back. So today we're going to do a career session. Probably people who have seen the posts today's comics is about getting career in quantum. And I will let people do the Q&A in a bit, but I will walk you through some of the slides that I have prepared on this topic. For anyone who's joining the very first time, I always show this to people that you can find all of the past recording for the class in the Hackaday. Oh, wait. Hear me clearly because I wasn't using the right microphone. Can you hear me now?
Yes.
Yes.
Great.
Yeah.
And so I always let people know that this is where you can find information. You can find all of the past recordings and slides, and the official documentation that we use is from Microsoft, is our Q# documentation, and we have been using the katas for training on quantum. So if you missed any of the previous classes, these are the places you can go to. And also, I'm very proud to announce that we were on Forbes. The quantum team's work were featured there, and our class was mentioned there, also including the comics. So check it out. This is on Forbes, October 18th on quantum. Just search for, don't have to have this URL, just search for the article there by Guild Press. Okay, and yeah, thank you. For people who have been following the class, you have learned a lot of the concepts that's needed for quantum computing, starting from the superposition, interference, and entanglement concepts, as well as linear algebra and using Q# to write algorithms. These are the topics that we already have covered in the past, I think 18 classes. So now you may want to ask, or even before you started the class, how do I get a job in quantum? And is it something that you've been thinking about? Maybe you have been working on something for a long time, but quantum is something new, and you may be wondering, this might be the good field to enter. So we would look at some of the career trajectories, examples of what kinds of skills are needed in quantum. So this captures the path for someone who start to learn quantum and the topics that they need to get their hands on it. But we can also look at the existing positions that we currently have in quantum, and that's what the industry needs. Guess I would first show my own trajectory. This is definitely not typical, but just to give you some background here, this is kind of my career path. Professionally, always been in physics, and started with condensed matter experiments and started doing circuit designs and did optoelectronics and photonics. But then I ended up coming back to quantum, where I started as an undergrad in Cambridge, working in the Cavendish lab. So I'm not working on hardware anymore, but I'm working on quantum computing on the education side. But it's using a lot of my past experiences. But all of these are actually also contributing to what I do now. My side projects on art, on fashion, on wearables, those are actually surprisingly very, very useful and helpful for what I'm doing right now. So this is how I found my balance, getting to do both science and art at the same time. And quantum has this interface for me to use my skills in both areas. But this is definitely not typical, and you can definitely forge your own career, and you have your own skills and uniqueness that you can leverage in presenting yourself as a unique person to help the industry. Let's do this. So I have prepared these characters. I think it was quite interesting that at the end of last class, people were asking me the names of the quantum characters. And I thought, actually, this would be a good idea to even show you who they are and where they sit on this landscape. Let's start with Peter. I'm going to actually do this connection. And people feel free to chime in if you want to participate in this identification. So Peter is an algorithm creator. So he discovers and proves the power of quantum computing, and he comes up with new ideas that could use quantum computers for, and invents an algorithm that solves that particular problem. We need a lot of people like that, and especially that you have seen in previous classes, there are algorithms that will be very useful. They require a lot of qubits, but there are also things that we can already start doing with a small number of qubits trying to learn. But in between, we also need a lot of effort to find applications of quantum computing that can start to help us do work. So people who come up with algorithms may come from a math or physics background. And I also want to mention is not definitely all of these characters have their different backgrounds. You don't have to have a PhD in physics to contribute to quantum. So Peter might have a PhD in math or physics, and he's particularly helpful in coming up with new algorithms and helping people apply and do interesting things. So he's gonna sit here. Let me change also the style. But then there are a lot of us, a lot of programmers and developers in quantum that they use the algorithms or they develop applications utilizing those algorithms, and they may also come up with new algorithms to write programs to solve particular problems. So in quantum, right now we have things like Schwarz algorithm, Groover's algorithm that are purely quantum, and there are also problems like chemistry simulation, material simulation that is also purely quantum that you need quantum computers to run. But there are also problems like quantum inspired optimization that's using quantum ideas but applying to classical problems. So those can also be that kind of quantum algorithm that could help us, even though they may be classical, but is using some quantum ideas. We have a lot of programmers. They may come from software engineering background, and they might not have learned quantum at all in their formal education, but then they pick it up along the way. So I will also put them over here in this algorithm category. But we also have people we need that need to run like layers of the languages on hardware. We need to actually build both the hardware and software stack that we'll be able to use in actual hardware. So I would also connect them there. Of course, they already understand the basics, linear algebra, and all these concepts, and they are writing these things on maybe Q#. They may come up with new, they might be language creators as well. They come up with the new language and they develop that. We also have people like James here, who is a researcher. So here, researcher, I particularly mean like natural sciences. I mentioned quantum simulations like chemistry, material science, biological simulations or physics simulations. Classical computers can run into limitations, and we want to use perhaps quantum ways to simulate them and understand how to come up with new materials. So James is in the research area, also needing the algorithms, and they also help us come up with ideas of doing hardware, making more types of scalable qubits. Their research can also contribute to that. We have Albert, who is an educator, and what they're very good at is explaining concepts, scientific concepts that could seem intimidating to people who just start, but then they have a very good grasp of it, and they can explain things in a very accessible way without making it just trivial and not teaching people anything, hyping it. So we definitely, in the new field of quantum computing, we need people like that. That, as you see, that this is an emerging field. We need a lot of people who's able to train more people to understand it. Otherwise, we wouldn't have the adoption from industry, or we wouldn't have new learners coming in, being able to contribute to the next generation of workforce. So a role like Albert is also very important. And they typically can sit over here, but they're really spanning all these areas because they need to communicate all the ideas that's involved. And but they need to explain very well. I just keep in mind that this line will go through this cable that goes all the way, but they would need to explain the basic concepts and theory. They can come from any, I would say, STEAM background, so they need the engineering and science understanding, but having the skills to communicate and doing art is extremely helpful there. They know how to communicate and talk to the public. And we need people like Ada, who is an early adopter. So without early adopters, any technology without early adopters is not going to scale. And they typically can be business decision makers. They don't have to be an expert in quantum computing, but they have the skill to understand it. They have a good idea of what this technology is about, and they are able to identify what problems in their existing industry might be able to utilize quantum computing. So these people need to self-train, definitely, and they need to have a good idea of what problems are not even applicable with quantum computing, because there's so much hype and everyone may think that, oh, quantum computer is going to replace classical computer, but we have seen that's not true. So they need to identify what are the problems. So we, of course, have a lot of learners, very passionate and curious about quantum computing. And their passion will drive them to dig deeper, to really discover all the new ideas in quantum and really get their hands dirty on working on quantum. And they will be able to join us as the next generation of quantum workforce. So they would not just learn a little bit and learn something shallow and then leave, but they would be able to grasp all of these through their personal exploration. So they for sure will start from the basics, but of course they need to go all the way to be able to really do this professionally. But they can come from any background as long as they have the ability and the drive to learn. So they don't have to have any PhD in any of the fields, but if they want to learn, they can do it. And Richard is a hardware maker. It is very broadly speaking maker. They can be designers, they can be engineers. They would need to understand the physics of the quantum system that they're building. Doesn't matter which hardware that they choose to make. Can be topological quantum computer, can be the LC circuit, semiconductor LC circuits, could be trap irons. They typically would need physics or electrical engineering or material science background. So if you are interested in hardware, then this would be some professional training that you would need to understand the hardware aspects and be able to build the systems. So that's there. It's getting a little crowded. I'll delete this in a bit. But then, as you can see, we have people coming to different areas with different backgrounds. It doesn't mean that if you are a software person, having understanding of the hardware is definitely helpful, but you don't have to have the same training as Richard. Whereas Richard is very good at hardware, having software understanding and being able to grasp what the software developers are developing is very helpful, but they don't necessarily need to come from a software engineering background. So we need a lot of interdisciplinary cross-section. So as a think out of the box person, you can be anywhere. You can assess your own background and know what you want to go, where do you want to go. And knowing that this is what you need, you would drive yourself from the basics to the professional. And this will be a certificate I will give out to people. So I have a challenge I just posted that on this picture here, you should find where any of the character was introduced in past classes. In the past pages, if you go through the comics, you will be able to find where they were introduced. And then find the video recording of that particular class. If you haven't watched it, go watch it, and then write down briefly what you have learned in that class. Post that on the comment section in Hackaday or do a tweet, LinkedIn, and Instagram, whatever way you want, but tag me and tag Microsoft Quantum and hashtag QSharp, and you will get this out-of-the-box thinker. But that's not the goal. The goal is that you actually learn something. So this will be a really fun activity for you later. The other thing I want to mention is contributing. I get a lot of questions from people who want to apply for jobs in quantum and asking what kind of skills they need. I have explained here, you can come from all kinds of backgrounds. But a very important thing is to show that you have the passion, the drive, and the ability to do quantum. And the very helpful place for you to do that is actually contributing to all of our open source libraries, repositories, and katas. All of these are already available for anyone to learn from and play with. And here are a lot of links, but where do you find it? You can actually find all of these on the Microsoft Quantum page. If people need, I can show you later on the browser. But all of these, just pick whichever that's helpful for you, start contributing. And by the time you're applying for a job in the interview or in your resume, you can even list that you have done this, and that's your very first entrance to prove that you not only are passionate about quantum computing, you actually done something. This is a great way for you to demonstrate. So don't wait for, yeah.
That's wonderful. I'm a project manager, so where I was wondering, and we have a project in the making where we want to establish some protocols and some best practices with quantum, preferably bouncing them off you. Where would we put that? Would that go in the last item?
No, that would not be the right place. I think the best way is to, once you have written that, you have a website or something that captures what you are doing, you can email us. And I think a good thing that you should also cross-check is to study existing efforts. From what you just said, there are a lot of programs, there are a lot of activities, meetups that's doing quantum, they're doing their own things, but there's so many of them. What is the special thing that you are doing, and can you collaborate with existing resources that have the same goal? I think coming together, working collaboratively would be a key for you.
Yes, and that's exactly what we're doing. But there's still the question of you're suggesting here's where you can collaborate, here where we can put in this 1, 2, 3, 4, 5, 6, 7 areas. I don't see a logical place for us to list our website with that collaboration. I'm happy with just sharing it with you once we're ready, and then you can advise me later privately.
Sure, that can work. So I don't know what you are doing. If it's not an official Microsoft project, then we have to look how we can support you.
Sure, I appreciate that. And I can take that up with Microsoft Canada as well. But thank you. You've answered my question.
Yeah.
David,
this is really for people.
A GitHub project.
Sorry?
I mean, David could also, start a GitHub project on that matter, and therefore that GitHub then can be put up on a public, or you can, it will be picked up anyway by the search engines and stuff. So I think GitHub could be a great place for that, because then it becomes more collaborative.
Yeah, if it's something that you can present in the way of a GitHub repo, then by all means do that. Yeah, I right now don't know what kind of program you're building, so keep GitHub in mind for sure. Yeah, and then here is a place if you haven't put in your opinions, your preferences in this survey, go do that. This is on our Microsoft Development Kit webpage. And here is a survey, is an opportunity for you to let us know what types of content that you want to do, that you want to learn. So it will be a great engagement and for us to develop the content that would be useful for you later too. So, and then quick announcement before we start the Q&A is next class, I'm going to take a day off from this class because I have a special project going on I really need the time for. So please go back to past classes if you missed any and give you time to catch up. So we would come back the week after and we'll talk about something about hardware. That was the only box that I hadn't highlighted, but we did do one class existing presentation of different kinds of hardware. So I think I will have some focus on particular hardware, so not all of them. If you need an overview, please go back to that class to take an overview before you come to this class next time. That's what I prepared to present, and I can open up the floor if people want to ask questions about starting a career in quantum.
Hi, Kitty. I have a question, and a slight addition, maybe in that career path, if that's okay, may I?
Yeah, sure.
Yeah. The question that I have is, with regards to the Azure Quantum, in the future, would that also allow other programs to also run, which are non-Microsoft? So, for example, IBM Q, for example, or Honeywell writing their own, they're also writing their own algorithm, for example, in their own language. And so would that open up to other vendors as well, a kind of vendor neutrality?
We already are working with.
I know Honeywell is there.
We already work with Honeywell, RNQ, 1QBit, and a lot of partners. So that's already there.
But what about IBM?
We will see. We'll see what happens.
But it's something that will come as in future, however it happens. Is that right?
That would in the future we'll have to wait and see. I can't give you the answer now.
Right. Okay. And the other two addition, I would say, I mean, from the commercial side in that picture, I think you could have a consultant who basically, proposes a quantum solution to, academia or industry or department or whatever. I think somebody who's a great, good at communicating, understands the quantum, but is not really hands-on. So that person could become a consultant, and then that person could also work with numerous quantum specialists to deliver a project, for example. Would you say that could be a career path as well?
That could be, yeah. I would think so. There are a lot of peripherals, for sure.
Also, sales, quantum sales, for example, or quantum optimizers, people who are good at optimization. Quantum cybersecurity, for example. Quantum military radar and all that other.
For sure.
Stuff.
Yes, just like everything else.
Yeah. All right. Thanks. That's all. Thank you.
I can add to what you mentioned there, Sumit. The CTO of IBM in the UK, who's I think the head cheerleader for their IBM Q hardware, expressed interest to pledge the future of the IBM Q to be part of our quantum computing to solve fusion project. So once I think the projects may pull them all together. And once I follow Kitty's instructions, and Microsoft Canada is helping us at the moment with this project. I believe they'll be pulling them all together. And as Kitty mentioned, there are many quantum associations. One of which is called Association Quantum, another Toronto-based quantum meetup, which again pulls in projects. So I see us all forming around Kitty's quantum computer for comics as an approach. Kitty, the approach that you use here is both inspiring and friendly and educational. So that's where my people and I all want to come with you. And what I'd love to do is also try and figure out where the music and fashion and the arts, performing arts, can be part of this. In that, I believe that we're at an inflection point in history where children are aware of computers. In grade school, they're learning how to program. The Hello World quantum computer project or algorithm we're looking to teach that to as young as possible. And Kitty, that's where you're an inspiration. In particular, coming back, Summit, I just wanted to mention, very exciting, where you mentioned some of the military hardware. We always want quantum computing to be used for good, but I appreciate your mention of that. Part of our contribution is a friend of mine at the University of Waterloo, a co-founder of their Quantum Institute, has some quantum projects involving security with satellites. So we'll pull all that together in a little GitHub, and I'm looking to document them with Kitty's kitties, the comic kitties, to relate the different aspects of where the project came together, which I think will inspire the young as well as bring in the technical geniuses. Maybe half of them in the world are on this meetup right now. We just haven't talked to them yet.
Great. Yeah, thank you. I will also add that it's very good to start the discussion about ethical quantum computing early, and there are applications that we should be very careful for, because technology can be used for good and evil. But I really want to, because today is Q&A for Korea, and I would love to give people the opportunity if they have any questions about their own or their friends' experience and what type of jobs are out there. So if people want to ask that, feel free to unmute or post in the chat. Yeah, thank you, Android developer. And I see a question from Todd as well. I'll answer that first. Is it better to target the open source projects or work towards functional applications at this point? Build a tool to add to the libraries already in existence, or work on a new application area for the technology? Both, really. Todd, go for it. Anything that's filling any gap is going to be very helpful for the whole field. Adding things to the library, definitely. You should go through that. That would help you learn a lot of the existing development, but you also find a lot of bugs and problems, and you come in and help everyone. Build new applications, definitely, because we need a lot more applications for quantum computing. We're just developing this new generation of computation and a lot of unknowns. I heard a lot about the analogy between this and when laser was first invented, because the inventor never would have thought that all these applications for lasers now that we do. So same goes with quantum computing. Android developer has a question. They have a Bachelor of Science in Data Science and Computing. The question is, I have entered Royal Astronomical Society poster exhibition. Congrats. Notice there is a lot of logic operators used in my comics. You mean the gates, the circuits? Should I clearly explain such areas using logic in my poster entry? Are you doing a quantum computing poster? And are you trying to explain a algorithm? I'm wondering what's, yeah, okay. So it's really up to you, whichever way you think is most easy to convey, because quantum circuit to represent algorithm is its own thing, is a representation people do have to learn. So for people who have never learned what quantum circuits are, if they look at it the first time, they may not be able to really grasp and understand it. That's why we actually spend some time in the class explaining how the circuit is written. And also for circuits, you can't really scale. If you have a really big algorithm, the circuit is only going to be helpful with a small number of qubits, and once you know how circuits work. So depends if you can explain it with words or with other types of graphics that's clearer for your audience, go for it. If you think they already understand gate logic circuits, then you can do that too. Any other question? Yeah, thanks. Doesn't have to be your own experience. You can ask for your friends, because I've been getting a lot of requests, so might as well do a session like this. Yeah, good luck.
Kitty, I have a question.
Yeah.
At York University, which is pulling together all the universities, we're looking at deploying the campus itself as a type of quantum sensor. This has to do with the environmental spin part of our project with the environment. The theory that we have going is that an energy information management system based on the energy grid with a SCADA, a supervisor control and data system. If we have enough IoT devices, the challenge is, I was just talking to TELUS, that's one of our telcos just before this call. If we have enough IoT devices to actually be useful to have fine granularity in terms of atmospheric interference, for example, or atmospheric anomalies, whether they're all health related, we're thinking we'd be overwhelmed by the data. That we wouldn't be able to compute it in real time fast enough, and for what we're looking for, the anomalies that would be issues. This is where quantum computers is a natural fit. I can't in this moment figure out what the logical path would be, but I instinctively realize that through the Kitty diagram of quantum computing careers, that the path would unfold. Do any of the roles that you just spoke of for an ideal application, both hardware and software, come to mind?
I don't quite understand the problem you're trying to solve right now, whether or not it's applicable with quantum computing. But I think the advice I would give is if you haven't done previous classes for understanding the concept of quantum computing and where they are, definitely go to those classes. Doesn't have to be from this class. You can read about superposition, interference, and entanglement, and try some algorithms yourself and have a better idea of what quantum computing is useful for.
Thanks. Well, we've done that actually, and the challenge is the Harvard PhD has a bottleneck with the current efficiencies of supercomputers. So this is where we need additional computing power. So this is where quantum computers are a natural fit. So it becomes a matter of the algorithms. I'm familiar with the algorithms that would be required for that. We may need a hardware play here. We're not sure about it. So I think what we'll do is I'll take this offline. I'll talk to my Harvard and MIT guy. We're going to formulate what we believe is the issue where the classical requirement ends, where we think the quantum starts. And this is where we think it's more than just a programming. But looking at your diagram, it occurred to me that we have to be open to a more of an interdisciplinary approach where we're looking at hardware that may not exist yet for our application. It's a 7-year project or so.
Yeah.
Is there any chance I could add something to that? I just wanted to add something to it.
I recommend you to connect offline. And if you want to bounce off ideas, I would recommend when the actual quantum becomes public, you can try it on actual hardware. So to formulate your problem with a quantum solution. So that's what I would recommend you do.
I appreciate it. Well, what we're doing is we're going to create in Q# first, because Q# operates off a quantum simulated hardware, and that way we don't have to wait for the hardware to show up, and it's just a matter of extending the computational ability beyond our current classical limitations. So what I do have the support from the IBM quantum Q guy, that when it shows up, it's there. We're just trying to anticipate and get it ready for when we expect the hardware to show up.
And also a reminder that the meeting is being recorded. So if there's any confidential information, you shouldn't share, or let me know if you okay with sharing, because this video is going to go on YouTube afterwards.
No, I appreciate it. This was information that was shared on a similar meetup. And it was a public declaration, so I do appreciate that.
Yeah, I have a question from SB. They're asking about sales and consulting or business side of technology. Most of the meetup are very technical, and that's good. But how would one work in future as quantum computer pre-sales engineer or architecture consultant? Oh yeah, that's a good question. Yeah, a lot of the examples that I gave are technical roles, but there's the early adopter that I included here that is relating to business and consulting. So that I would recommend the same thing is they need to be at least have some basic understanding of how quantum computing works, and then be able to tell that what type of problems is useful using quantum computing. So it's the same that you will have to at least know these areas to be able to move forward with your applications. So yeah, there are a lot of people out there doing quantum business, and early business development is also very important for this field. Is there scenarios where quantum computing should not be used? Plenty, because what classical computers can already do very, very well, you don't have to use quantum computers. It's not a replacement. It's not that if your quantum computer, if your classical computer can already be used to drive an airplane, you don't have to use a quantum computer to do that. You could, but why would you? Because you don't want to overkill. So I think finding the problems quantum computers can solve is more urgent. Todd asks, in the field as it sits right now, is the work more focused on design and algorithm creation, or more towards development and creation of code to utilize, to get an idea of the day-to-day for a developer? It's all of them, really. We have developers in the actual Q# language, and we have developers who build algorithms, who write algorithms and work with customers to come up with solutions, helping them expressing their problems into quantum representations. We also have developers who work on the compilers, because it's a language, you need a compiler for computation. We have developers who work on the integration of the language with particular hardware, different kinds of hardware. So Q# is a language that runs with classical language as well, and is got great interoperability. So we intentionally invented this new language in order to do actual quantum computation. So it's not a modification of an existing language, is its own. So that's the advantage of that. And yeah, so all of these different types of developers that we currently have a great pool of talents, but we also need a lot more. Yeah, thanks. Any other questions about your own experience? So it doesn't have to be your own thing. You can talk about your friends too. Sanchi says, an open-ended question. Perhaps one of the attendees could help out. Yeah, that would be great. If anyone knows, you can feel free to post or connect yourselves offline. They're currently pursuing masters in scientific computing, where a lot of their courses involve finite volume or finite element methods, okay, applied to magnetohydrodynamics, radiative transfer, etc. They're wondering if there is some way that they could use skills from, say, FEM to quantum computing, or perhaps as a possible application on quantum computing. I think so, yeah. You're doing a lot of, I guess, simulations. And we actually also build simulators for quantum hardware. And we also have resource estimators to estimate how much resources, how to run an algorithm, how many gates, what's the quantum volume that's needed. So that type of skill is also very important, very helpful there. And perhaps you can definitely come up with applications for quantum computers. Perhaps the problem that you're solving has to be solved with a quantum computer, or it will be hard for a classical computer, but then becomes easy. Like I can think of some simulations I did, like back in grad school, simulating graphene is a one sheet layer of graphite is sandwiched in between a bunch of other materials. And to simulate that one layer was extremely hard because the mesh point would be very different. The mesh for other materials are much larger, but then when you want to simulate one layer, you can't really make such a fine mesh and force a computer to do that because it would not finish simulation. So we did model it differently with electrical engineering methods, just treating it as a special metal layer. But I guess if perhaps we would need at some point simulating each carbon on a graphene layer with a quantum computer, that might be very interesting. But depends on what you're trying to do. More of the quantum simulations. So actually, you can read all about that on the quantum computing documentation. Let me show you. This is our documentation that our class is also heavily based on. We have all the information that you need about Q-sharp, and we have the user guide with the simulators and resource estimator explained. You can read a lot about them just from the documentation. So here you are. That's what you need there. And earlier I mentioned the links to open source is under resources you can find in how to contribute to QDK. All of the links are here. We also let you know how the community can contribute. And here are the open source repos that you can already start working on. Sanchi has a follow-up. Oh yeah, I have a hard time understanding the suitable use cases of quantum computing. Yeah, so in our class, we gave some examples of algorithms that can really use the power of quantum computers, but for sure we need a lot more. And today, what you can do, what you can already use quantum logic for is the quantum inspired algorithms. They are intrinsically classical problems that can be formulated in a quantum manner. Say you want to optimize your like spending or logistics, you can describe your system into a Hamiltonian to solve the eigenstate of your matrix. Then that gives you the minimum point of your cost. So that's one example that a lot of industries already adopting with quantum inspired methods. For actual quantum, we have just a lot of work on developing the hardware that can run these useful algorithms, quantum algorithms. I think I just saw another question there. to stop sharing this. Team is getting a little stuck. Nathan says use Anson's tools in their team for electromagnetic, mechanical, and thermal simulation. Yeah, I use COMSOL for my simulations. You mentioned that that's Eleanor, classical computing would exist alongside quantum computing. How are we dealing with security problem related to non-quantum cryptography? Is it likely that quantum safe algorithms are implementable on classical computing systems at large scale? Yeah, it's a great question. I don't know. I'm not familiar with cryptography and how that implication is, but Taro in our audience, he may be able to give you much more answer to that on quantum cryptography and post-quantum cryptography. Cool. Sumit haven't yet become a problem. Yeah, I think we have to worry about it though. We have to think about it. Oh, Taro mentioned a course tomorrow at 1:30 Eastern USA. You can share. I know Taro posted the link to their meetup. You can check it out. They actually consolidated a lot of resources from all kinds of quantum meetups.
So with regards to cybersecurity, I just wanted to add on that there are, for example, certain algorithms such as, for example, DES or even TLS 1.0. You can actually grab the random number generator, for example, or even the keys. But the idea in quantum is that obviously you can almost have a true randomness. So that itself protects against it. But currently, the quantum computers are not powerful enough to actually break a 2048-bit encryption, for example. But in the future, it will be. And as I mentioned last time, the lattice-based cryptography is the one that's already in place. And DoD and where it really matters, they're already implementing lattice-based cryptography, which will not be impacted by quantum computing. So that's all I wanted to add. Thanks.
I think we can also, if anyone in the audience interested in giving a presentation, feel free to let me know and we can set up a time. Sumit, if you want to give a class on that, that would be nice. So let me know, ping me, or I think directly just write on the Hackaday page in the comment section if you want to teach any particular topic.
I'm happy to cover, how classical cryptography works and what stuff will change in the future. But we can agree on a time. Yeah, I can do that. Thank you.
Mm-hmm. Yeah, Thomas comments, classical computers can also connect and make use of quantum devices. Yeah. Yeah, I guess we could have a specific topic on quantum cryptography. I would love to learn that too. LG mentions they would like to reach out and assist anyone with IoT sensor data. Great. Maybe David, you can connect.
Yes, thank you.
Cool. Thanks, everyone. Let's finish for today. Want me to live draw comics? I can try. All right. Thanks, everyone. See you not next Sunday, but the week after. Bye.